Hello everyone. Today we will solve Chemistry JEE Mains 2020 model question paper. 26th question is an electron returned from excited state to ground state in hydrogen atom and emits a photon of wavelength lambda. The principal quantum number of excited state is given by. Here you need to calculate the principal quantum number of excited state. Okay, so for this we will use the formula, that is Rydberg formula. According to Rydberg formula, we will write 1 by lambda is equal to R 1 by n1 square minus 1 by n2 square. This is the formula that we know. Now here n1 represents the principal quantum number of ground state, n2 represents the principal quantum number of excited state, and lambda is wavelength, R is Rydberg constant. So here I will rearrange this equation and I will cross multiply this R. So 1 by lambda R is equal to 1 divided by n1 square, that is n1 is ground state, so the value of n1 will be 1. Whenever the electron is present in ground state, the n1 value will be considered as 1 only. So 1 square is 1 minus 1 by n2 square, that you need to calculate. The n2 value you need to calculate, that is the principal quantum number of excited state. Now this can be written as 1 by lambda R is equal to 1 minus 1 by n square. Okay. Now 1 by n2 square is equal to what it becomes, 1 minus 1 by lambda R. So I have simply moved this here and taken at this left hand side. So it can be, on rearranging, it can be written as 1 by n2 square is equal to 1 minus 1 lambda R. Therefore n2 square is equal to what it becomes. So see here, it can be written as lambda R minus 1 divided by lambda R on taking LCM. So 1 by n square is equal to lambda R minus 1 divided by lambda R. Then n2 square, taking the reciprocal, what it becomes on right hand side also, it becomes lambda R is equal to lambda R divided by lambda R minus 1. Therefore n2 is equal to, this is the value of n2 square, but we want n2, therefore it becomes lambda R divided by lambda R minus 1 square root of lambda R divided by lambda R minus 1. This is the value of n2. Therefore, just to see these options, which one is the right answer here? Option C. This one is the right answer. Next, moving to the second question, that is 27th. First ionization energy is lowest for carbon, tin, lead, silicon. Okay. So here these are all our same group elements, and among these the ionization energy is lowest for. As you know, as we move down the group, the ionization energy decreases. As we move down the group, ionization energy decreases. Okay, so carbon is placed like this, then silicon. These are the 14th group elements. So carbon first, it is the first member, silicon, then the next one will be the tin, that is denoted as Sn, and then lead. As you know, if we move down the group, ionization energy decreases. So carbon is having high ionization energy, silicon is also having high ionization energy as compared to lead and tin. Now in this case, instead of, as we follow the trend, we can say lead is having the lowest ionization energy. But actually the tin is having lowest ionization enthalpy or ionization energy. It is because in tin there is a poor shielding of, due to the poor shielding of D and F electrons, due to the poor shielding, or you can also say it as screening effect of D and F electrons, the ionization energy for tin is lesser than lead, and hence among these four options the tin is having the lowest ionization energy. Option B is the right one. 28th, amongst BCl3, CO3 minus 2, NO3 minus, ClO3 minus, SO3 minus 2, PO3 minus 2, ASO3 minus 2 and SO3, the non-planar species are. These are the given options. Now how you find out which one is a planar species and which one is a non-planar species? Planar species means they must have sp2 hybridization. Okay, if the molecule or compound is having sp2 hybridization, then it is said to be a planar species. Okay, triangular planar species. And if it is having sp3 hybridization, then it is non-planar. That is, it may have tetrahedral or distorted tetrahedral structure. And if it is having sp hybridization, then the compound is said to be linear. Therefore, in order to find which one is planar and which one is non-planar, we should know the hybridization. And how we can know the hybridization of these molecules? So for that, let us consider any one of these molecules. So let us consider BCl3. Is it a planar or non-planar? That we need to calculate. So BCl3, how we calculate? Is it a planar, non-planar or linear? In order to calculate that, we should know the sp2 or sp3 or sp hybridization, and in order to find that hybridization, we should take the number of valence electrons, the atoms which are present in this molecule. So boron, first take the boron. How many valence electrons are there in boron? The electronic configuration can be written as 2, 3 for boron. Okay, because atomic number is 5. And for chlorine, the atomic number is written as 2, 8, 7. Okay. Therefore, the number of valence electron in B is 3 and number of valence electrons in Cl is 7. Just add those valence electrons. Take the sum of valence electrons first. So in BCl3, there are totally how many valence electrons? 3 plus. In one Cl, 7 electrons are there. But here how many Cl atoms are there? 3 atoms. So 3 into 7. How much you will get? 3 into 7, 21. Therefore, 3 plus 21 is equal to 24. And upon taking the number of valence electrons, you should divide it by 8. When you divide it by 8, you will get the quotient and remainder. So simply divide the 24. Okay, you should mention the quotient and remainder. So 8 3s are 24. So 24. How much you will get? 0. So this is the quotient and this is the remainder. After calculating the quotient and remainder, you have to add up that quotient and remainder. Upon addition of quotient and remainder, how much you will get? Quotient is 3, remainder is 0. So 3 plus 0 is 3 only. When you get 3, okay, then that type of hybridization the molecule will undergo will be sp2 hybridization. Okay, sp2 hybridization. Suppose if you get the value as 4, let us consider x is equal to 4, this x is equal to 3. If x is equal to 3, it is sp2 hybridization. If x is equal to 4, it is sp3 hybridization. Okay, and if x is equal to 2, then it is sp hybridization. Okay, and represents it is a linear, it is non-planar, and sp2 means planar. Okay, so that you should know. First, what you have to do, you have to calculate the total number of valence electrons in molecule or any compound which is given. So first step, then divide the valence electrons by 8, total number of valence electrons by 8. Then take the quotient and remainder obtained after division. Okay, after division you will get the quotient and remainder. The remainder again it is divided by 2. R should be divided by 2. After that, take the sum of Q plus this R which is divided by 2. Okay, here only I have taken. Since here it is 0, so I have not divided it. If it is other than 0, then you have to divide it by 2. Because if you get 0, 0 by 2 is 0 only. Therefore, I have not mentioned. But in general, we have to divide the remainder by 2. Then you will get the type of hybridization. Suppose you will get some value x is equal to 3, that represents it will undergo sp2 hybridization. So here only I will write it. If x is equal to 3, sp2, x is equal to 4, sp3, x is equal to 2, sp hybridization, and these are the structures of those molecules. Okay. Now BCl3 will undergo sp2 hybridization. Since it undergoes sp2 hybridization, its structure would be planar. Now they asked for non-planar species. So option A consists of BCl3, therefore it is a planar species, and it is also, the option B also consists of BCl3, this option is also not possible. Option C also consists of BCl3, this option is also not possible. Option D does not consist of BCl3, but you have to check whether any one of these ion will obey the planar structure, whether any one of this will show the planar structure or non-planar structure. So first one I will consider SO3 minus 2. SO3 minus 2. So totally how many valence electrons are there? In sulfur 6, and in oxygen there will be presence of 6, and 6 3s are 18. Okay, so 3 oxygens are there. From each oxygen 6 electrons are there, valence electrons are there. So 6 into 3, 18. Along with that 2 electrons are gained. Those are also present in valence shell only, that is outermost shell only. Those are also considered as valence electrons. So 6, 18 plus 2, 6 plus 18 plus 2, how much it becomes? 6 plus 18, it becomes 24 plus 2, 26. So total number of valence electrons is 26. Then divide by 2. After dividing, you will get how much? The quotient and remainder you need to get. Therefore 26, and here write 8. 8 3s are 24. So how much you will get? 2. It is the remainder, it is quotient. Now what I have told you, R should be divided by 2. Therefore R by 2 gives 2 by 2 is equal to 1. Now at last step, take the sum of Q plus R by 2. Q is how much it is? 3 plus R by 2 is how much? 1. Therefore, value of X will be 4. If it is 4, then it represents sp3 hybridization and the structure is non-planar. Therefore, option D is the right answer. This is how you can able to find this species, whether it is planar or non-planar. Also, if they asked you to find the type of hybridization, then also it is very helpful. Next, 29th question. The oxidation states of S atoms in Marshall's acid and Caro's acids are. Marshall acid, it is having the formula H2S2O8, okay, which is also known as peroxydisulfuric acid. Peroxydisulfuric acid. Its structure will be given as S double bond O double bond O OH, and here O S double bond O double bond O OH. This is per-disulfuric acid, which is named as Marshall's acid after the discovery of this acid by scientist Marshall. And here, what is the oxidation state? As you can find here, 2, 2, 4, 5, 6. Totally 6 bonds are there. That represents S is having the plus 6 oxidation state. In both the S, if you observe both S, it is having the oxidation state plus 6. Now, another one is Caro's acid. Caro's acid, it is nothing but peroxy monosulfuric acid. Monosulfuric acid. Just remember the names. What is Marshall acid and what is Caro's acids? These are named after the discovery by a scientist. The Caro is also the name of the scientist, whose structure is given by S double bond O double bond O OH, and here OH. And as you can observe here, the oxidation state of S, here also it is plus 6, and hence both are having the plus 6 oxidation state. Therefore, the option D is the right answer. 30th question. Which of the following compound does not decompose on heating? If you observe NaHCO3, this will get easily decomposes and forms Na2CO3 along with the liberation of water. Okay, NaHCO3 on heating, it will decomposes to Na2CO3. Okay, and calcium bicarbonate, that will also on heating decomposes to calcium carbonate. Okay, this is the basic thing that you should know. Bicarbonates, upon decomposition, they will form carbonates along with the release of water. Now the problem is, along with the Na2CO3, they have given MgCO3. Now among these two, which one will undergo decomposes? That is on heating, which one will undergo decomposition? Here MgCO3 and Na2CO3, among these two, which one is having more electropositivity nature, or which one is having more electropositive value? As you know, down the group, the electropositivity decreases. Down the group, electropositivity decreases. Therefore, Na plus is having more electropositive value than Mg plus 2. And greater the electropositivity, stronger will be the bond formed between the electropositive atom and electronegative atom. Therefore, the bond between Na and CO3 is much stronger as compared to Mg and CO3. Therefore, Mg will undergo decomposition on heating, but Na2CO3 will not undergo decomposition upon normal heating. But at a very high temperature, if you heat, then it will decompose. But normally, among these four, at a normal heating, the sodium carbonate will not undergo decomposition. Therefore, option C is the right answer. 31st, find the PO bonds which are present in P4O6. So here the structure of P4O6 is given like this. Now just calculate the number of bonds which are present here, PO bonds. This is one bond, 1, 2, 3, 4, 5, 6, 7, 8, as well as 9, 10, 11, 12. Therefore, there are totally 12 bonds are present. 12 PO bonds are present. Therefore, option A is the right one. 32nd question. When hydrogen peroxide is added to acidified potassium dichromate, a blue color is produced due to the formation of. So reaction of hydrogen peroxide with potassium dichromate, that is given by K2Cr2O7 plus H2SO4, acidified it is, therefore we have taken H2SO4 and hydrogen peroxide. When they are reacted with each other, it will form chromium oxide along with potassium sulfate with water. The blue colored compound that is obtained will be chromium oxide. Therefore, the option D, that is CrO5, is the right one. 33rd, if BOD of a river is high, it means that the river is. First of all, you should know what is BOD, biological oxygen demand. That means in water, if organic chemicals, amount of organic chemicals increases, in order to decompose that, the microorganisms require certain amount of oxygen. That amount of oxygen which is required to break down or decompose the organic materials which are present in the water is said to be BOD. Now, if BOD of a river is high, that means more amount of oxygen is required to decompose organic chemicals, because more amount of organic chemicals are dissolved in that water. So in order to decompose them, the microorganisms requires more and more amount of oxygen. Therefore, among these options, option A here, polluted by pesticides, not polluted, polluted by inorganic chemicals, polluted by organic chemicals which are decomposed by microorganism. So option D is the right answer. So if you know the definition of BOD, you can easily take the correct answer. 34th, which of the following has unstable enol form? So these are the ketones, ketonic forms, and you know, if the compound consists of alpha hydrogen atom, then it will form keto-enol forms, and which is known as keto-enol tautomerism. Among these four, which one is having unstable enol form? So if you see the first one, you can get, so this is the structure of the keto form. So this is the option A, the keto form. Now what would be the enol form of this? If you consider this one as alpha hydrogen atom, okay, so it becomes like this, okay. By delocalization, this pi electron shifted to here, and the hydrogen atom, the alpha hydrogen atom which is present, will be attracted by oxygen and becomes OH. Remember, the keto-enol tautomerism, it can be observed only if the compound is having alpha hydrogen atom. And when you observe this, this is anti-aromatic. Anti-aromatic means it does not show aromaticity. Why? Because it does not obey Huckel's rule, that is 4n plus 2 Huckel rule. It does not obey Huckel rule. See how many pi electrons are there here? 4 pi electrons are there. Therefore you will not get 4 into 1 plus 2. How much you will get? You will get 6, but you won't get 4. Or if you substitute 0 here, how much you will get? 2. If the compound shows 6, 2, or again if you 2, then it will give 10. So if the compound is having these values, then it should be aromatic. And if it does not have these values, then it is said to be anti-aromatic. And since it is anti-aromatic, it is highly unstable. Again, if you can observe here, if you consider this compound, what would be the enol form of this? Simply, it is a alpha hydrogen atom in the given compound. Here it is a alpha hydrogen atom. Therefore, the delocalization of electrons will take place, and hence it becomes OH, and here it becomes double bond, double bond, double bond. So now calculate here how many pi electrons are there? Totally 6. So 6 pi electrons means 4n plus 2. Will it obey this rule? Substitute 1 in place of n. How much you will get? 6. Therefore, it is aromatic. In the similar manner, this will also, here also you can observe the electrons get shifted here, and hence it will form OH. Whether it is this one, you can take this one side or this one side. Then what would be the number of pi electrons? 2, and hence 4 into 0 plus 2, it gives 2. Therefore it is also aromatic. In the similar manner, if you observe option D, it will undergo ring formation, and hence this is also stable. And therefore among these 4, the option A, the first one, is having unstable enol form. Okay. 35th. The major product P is for this reaction. So how you can write this reaction? This can be shown like this. Initially it is catalyzed with acid. It is an acid catalyzed reaction. So upon H plus, addition of H plus, what it gives? It gives OH, and then the delocalization will takes place. Here O will attract the pi electrons, and thus these pi electron gets delocalized and it becomes OH, and after that the double bonds come here, it becomes OH, and here the positive charge is placed. Now this will undergo ring expansion. Okay, this is how many rings are there, how many bonds are there here? 1, 2, 3, 4, 5. Then it becomes 6. It becomes 6 membered ring. It is said to be ring expansion. Upon ring expansion, it gives a positive charge here at this carbon, and it will remain as it is. And at the last step, the H plus gets removed, and thus it becomes OH double bond, and here also you will get double bond, because one of the H will get displaced. Okay, and the bond will move to here, and thus the compound that you will get will be this one. Therefore, which option is the right one here? Option D is the right answer. 36th. In a solid cation, P occupy 1/8 of the tetrahedral voids and cation Q occupy 1/4 of the octahedral voids, and oxide ions are arranged in cubic close packed structure. The formula of the compound is, just write down, the P will occupy 1/8 of tetrahedral voids. As you know, if the number of particles is n, then the number of tetrahedral voids formed will be 2n, and number of octahedral voids formed will be n. Therefore, P will occupy 1/8 of tetrahedral voids, that is 2n. Let us write it as in general 2n. Now, Q occupy 1/4 of octahedral voids. So number of particles will be n. Here simplify this, 2 1s are 2 4s are. How much you will get? 1/4n, and this is also 1/4n. And oxide ions are arranged in cubic close packed structure. Oxide ions, okay, let us represent them as O. Since they are arranged in cubic close packed structure, that is nothing but CCP, or you can also call it as FCC. So the number of particles in CCP or FCC is 4, and hence it is 4. Now write down the formula QO. These are the three compounds, three elements which are present. So P, what is the value of P? P 1/4n, Q 1/4n, and O is 4. Now n get cancels. What it becomes? P 1/4, Q 1/4, O 4. But as you know, the elements are not combined in fractions. Always they are combined in whole numbers, and hence multiply this whole thing by 4. How much you will get? P1, Q1, and it is 4. Okay, these two are not combined in fraction whole numbers, hence we have multiplied it by 4, but this is present in whole number only, so no need to multiply this with 4. Therefore the formula becomes PQO4. Therefore the option C is the right one. 37th, in a 0.5 molar aqueous solutions of weak acid HX, the degree of ionization is 0.20. The freezing point of the solution will be nearest to, given that Kf of water is 1.86 Kelvin kg per mole. Now, as you know, alpha is nothing but degree of dissociation. What is the value of that alpha? 0.20. Now, find the Van 't Hoff factor first, because they asked you to calculate the freezing point of the solution. You know, Tf naught is equal to freezing point of pure solvent, and Tf is equal to freezing point of solution. And to calculate, you should know delta Tf, because delta Tf is equal to Tf naught minus Tf. And Tf naught, it is the freezing point of solvent. Which solvent is given here? Water. Therefore its value is 0, and you need to calculate Tf, that is delta Tf is equal to 0 minus Tf. So bring this minus Tf is equal to delta Tf, or Tf is equal to minus delta Tf. Therefore you should calculate delta Tf. And how you calculate the delta Tf? Delta Tf is equal to plus Ki into Kf into m. Because in order to calculate Tf, you should know the delta Tf, and that delta Tf can be calculated by this formula. Because here they have given the 0.5 molar, that is the value of m. Therefore m is equal to 0.5 m. And Kf is also given, that is 1.86. So you need to find the value of I. Therefore I is equal to, how it is given? I is equal to 1 plus alpha. And now 1 plus alpha is 0.20. Therefore it becomes 1.20. Substitute the value of I, Kf and M in this equation. What you will get? Delta Tf is equal to 1.20 into 1.86 into M is 0.5. On substitution and multiplying, you will get plus 1.116, that is delta Tf. So what you want? Tf. So Tf is equal to how much? You already know, that is minus delta Tf. So minus delta Tf. Delta Tf is plus 1.116. Minus delta Tf means minus 1.116 degree Celsius. So the freezing point of the solution will be nearest to minus 1.116 degree Celsius. That is option C is the right answer. 38. Which of the following complex has lowest value of magnetic moment? How you calculate the magnetic moment? It is calculated by mu is equal to square root of n into n plus 2 Bm. It is Bohr magneton unit. So first, higher the value of n, greater will be the magnetic moment. Therefore, simply calculate the value of n. By knowing the value of n, you can able to say which one is having lowest value of magnetic moment. So what is n? N means number of unpaired electrons. So see the option A, Cr. What is the oxidation state of Cr in option A? So total overall charge is plus 3. Therefore, the oxidation state of Cr is plus 3 because NH, it is having 0 oxidation state. Now calculate the number of unpaired electrons. Before that, write the electronic configuration 3d3 4s0. Just go through the atomic number. There you can observe the electronic configuration of chromium, and here plus 3, it means it has lost 3 electrons. So remove the 3 electrons, you will get 3d3 4s0. Therefore number of unpaired electrons will be 3. In option B, Mn. What is the oxidation state of Mn here? Mn plus 2. Now write the electronic configuration 3d5 4s0. What would be the value of N? 5. Option C, CO. What is the oxidation state? Plus 3. Therefore 3d6 4s0. Now how many N are there? What is the value of N? That is means how many number of unpaired electrons are there? N is equal to 4 because 6 electrons are there. You can represent it as 1, 2, 3, 4, 5. After 5, the 6th electron will get pair up. Therefore, number of unpaired electrons will be 4. So in nickel tetracarbonyl, the oxidation state of nickel is 0 because carbon monoxide, its oxidation state is 0. That is a neutral atom. Therefore, here the number of unpaired electrons. What is the electronic configuration? 3d8 4s2. So number of unpaired electrons will be how much? 2. You will get 1, 2, 3, 4, 5. Then pairing will takes place. So number of unpaired electrons will be 2. And hence N is equal to 2. Therefore, among all these 4, the lowest value is nickel tetracarbonyl. It is having lowest magnetic moment. So 38th option D will be the correct one. 39th, which of the following is not an antiseptic? Option A, biothanol. Option B, 0.2% solution of phenol. And option C, ranitidine. Option D, dilute aqueous solution of boric acid. You know the ranitidine. Ranitidine, it is used for reducing the acidity. That is, it acts as antacid. So it is not an antiseptic, and hence option C is the right one. Remaining these are antiseptics. Okay, but they ask which one is not an antiseptic. So option C is the right one. Next, 40th question. Which of the following is not condensation polymer? If you have studied the synthesis of the polymers, there you can see the Dacron, Glyptal and nylon. These are all formed by condensation polymerization, but Teflon is formed by addition polymerization. Therefore, option C is the correct answer. The 41st question. Find the products A and B. So in this question you need to find the B. Okay, the answer among A, B, C, D option, which one is the B product? But to find B, you should know the A. So what is the reaction? CS3ClCOH. Okay, it is a carboxylic acid. And now when it is treated with thionyl chloride, the OH group, it is replaced by Cl and it becomes COCl. That is acyl group. It becomes acyl group. Therefore, the product obtained will be C double bond Cl. This is the product A. Now upon reacting it with aniline, okay, aniline, it is a weak base. So where it substitutes? It substitutes at chlorine and forms Cl double bond O NH, the benzene ring. So this is the compound which is obtained at the end, which is B. So among these, which one is the right answer? So among these, the correct option is option A. The 42nd question. In the given reaction, the major product is. So which is the major product here? First, what reaction will take place here? It is alkyl chloride. When it treated with aqueous KOH, what it gives? Here CS2Cl is there, KOH, OH will displaces Cl. It is proceeds through either SN1 or SN2 reaction and forms the product which is given as like this, which is A. Now again, upon acid catalyst, it is an alcohol compound now. Upon using the acid as a catalyst, it will undergo dehydration to form alkene, and that product will be an alkene. And again, upon oxidation in presence of zinc, it will form an aldehyde, which is written as like this. And finally, upon treating with NaOH, okay, it will undergo aldol condensation. Upon aldol condensation, it gives the product aldehyde. Okay, so this is the major product which is obtained during the reaction. So option B is the right answer. 43rd. In the given reaction, identify A. So they have used zinc amalgam with acid. This is one named reaction that is very important for you, that is Clemmensen reduction. Clemmensen reduction. So what does Clemmensen reduction says? When a ketone group is reduced to, when a reaction of aldehyde with zinc amalgam takes place with concentrated HCl, it forms the corresponding hydrocarbon. So by simply observing the options, you can write the answer. So what it becomes? OH is replaced by Cl, okay, then it can be written as Cl. It is converted, OH is converted into Cl, and ketone group is converted into hydrocarbon. That means it gets reduced to hydrocarbon. Therefore, the product obtained will be option. Which option is right? Option D is the right answer. 44th. In the given reaction, how many products are formed in major amount? So here the reaction scheme is given. Okay, so ring expansion, acid catalysis, all these things takes place. Just to go through this reaction, you will get the single final product. Okay, that is option 1. Then 45th, which of the following is non-reducing sugar? As you know, glucose, maltose and lactose are reducing sugars because carbonyl group is present in hemiacetal form. But in sucrose, it is a non-reducing agent, a reducing sugar, because C1 of glucose and C2 of fructose are present in acetal form. Okay, therefore option B is the right one. So these are all the questions where you will get the options. The 46th question will be of numerical type, and you only need to solve these questions. So first, 0.3 mole of NaCl and 0.3 mole of CaCl2 were dissolved in water to produce a 800 ml solution. The molarity of the Cl minus ions is. So you need to calculate the molarity, very simple one. Molarity. So molarity is equal to, how you calculate the molarity? Number of moles divided by volume of solution in liters. Volume of solution in liters. Number of moles of solute. So the molarity of Cl minus ions is. Therefore, you need to find the number of moles of Cl minus ions. So how many number of moles of Cl minus ions are there? Just see here, 0.3 mole of NaCl. It means 0.3 mole of Na ions are there and 0.3 mole of Cl minus ions are there. And similarly, 0.3 mole of CaCl2. So therefore, here also you can write it as 0.3 mole of Ca plus 2 ions are there and 0.3 mole of Cl minus ion is there. But how many Cl ions are there? 2. Therefore, 0.3 into 2 is equal to 0.6. So totally the number of moles of Cl minus ions will be how much? 0.3 mole of Cl minus, here it is present, and 0.6 mole. Totally how many moles? 0.3 plus 0.6. So 0.9 moles divided by volume of solution in liter. The volume is 800 ml, but the formula is in liters. So convert that into liter by dividing it by 1000. So when you divide it by 1000, it gets converted into liters. So what it becomes? It comes here, the value becomes 0.9, 800 into 1000. How much you will get? You will get 900 divided by 800. That is equal to how much? 1.12. That is the molarity, capital M, molarity of the Cl minus ions. In 47th, in the given half cell, the iodine gets converted into I minus which is connected to H plus and H2 half cell, and EMF is found to be 0.7714 volt. If standard electrode potential of iodine is 0.535 volt, the pH of H plus bar H2 half cell will be, you need to calculate the pH. Before that, you should know one equation, that is Nernst equation. E cell is equal to E naught cell minus 0.0591 divided by N log concentration of reactant divided by concentration of product. Concentration of product divided by concentration of reactants. Now, first you should know what are the products and what are the reactants. So first reaction, H2 will get converted into H plus with giving 2 electrons, and the iodine will get those 2 electrons and it becomes iodide ions. Therefore overall reaction will be given as 2H plus, okay, 2H plus, can be given as H2 plus I2, that gives 2H plus and 2I minus. Now these are the reactants and these are the products. So now these are the products obtained during the reaction. Therefore E cell is equal to E naught cell minus 0.0591 divided by 2 log H plus square I minus square divided by pressure of H2. Okay, since hydrogen is a gas, you have to take the partial pressure of hydrogen gas, and here 2 H plus ions are there, so concentration of H plus square is written. Now substitute the values. E cell, that is cell potential, is how much? It is 0.7714. 0.7714 is equal to E naught cell, standard potential value, that is also given, that is 0.535 minus 0.0591 divided by 2 log H plus square. I is how much? I is, that is 0.1 m, iodide ion, its concentration is 0.1 square divided by, what is the pressure of hydrogen? That is 1 bar, that is also given, so it is 1. Now simplify this. 0.7714 minus 0.535 into 2, just I have cross multiplied this, okay, then divided by 0.0591, that is equal to minus log of H plus square into 0.1 into 0.1, that is 10 square. I will write it as 10 raised to minus 2, 10 raised to minus 2, because 0.1 into 0.1 is 0.01, that is nothing but 10 raised to minus 2. Now again solve this. How much you will get? Upon solving you will get 8 here, and here minus log H plus square into, so take the minus sign outside. Here what you will get? 10 raised to minus 2. Log, this is in the form of log m into n. Therefore what it becomes? Minus 2 log H plus minus 2 log 10. Log m into n means log m plus log n. Therefore log m means log H plus and log n means log 10, and I have taken the minus 2 here because log a raised to n is nothing but n log e. Now solve this, what you will get, minus 2 log H plus, okay, plus minus into minus plus, and log 10 is how much? 1. Therefore 2 into 1 is 2. So here 8 is there. Bring this 2 at the left hand side, you will get minus 2. So minus 2 log H plus. So now 8 minus 2 is 6 is equal to minus 2 log H plus. I will write it here, or see here only 2 ones are 2 3s are. So 3 is equal to minus log of H plus. So what is minus log of H plus? Negative logarithm of H plus ion concentrations is nothing but pH. Therefore pH is equal to 3. So the pH of the H plus or H2 half cell will be 3. 48th, PQ3, which is a gas, dissociates as PQ2 plus half Q2. When the initial pressure of PQ3 is 400 torr and the total pressure developed at equilibrium is 450 torr, what percent fraction of PQ3 is dissociated? So this is the reaction. PQ3 is gives PQ2 plus half Q2. Okay. Now initially what is the pressure? Initially 400 torr pressure is there and these are not formed, so the pressure is 0. At equilibrium certain pressure has been changed, that is 400 minus P, and its pressure becomes P and its pressure becomes P by 2 because it is half. So the total pressure at the equilibrium will be 400 minus P plus P plus P by 2. This gives 450, that is total pressure. So minus P plus P get cancels. So P by 2 is equal to 450 minus 400 is equal to 100. 450 minus 400 is 50. 2 into 50 is 100. So I have directly written here. Therefore, what they have asked? Percentage fraction of PQ3. So you need to find the percentage of PQ3 dissociated. That is equal to 100. That is the pressure. And overall pressure that is present initially is 400. And you need to calculate the percentage. So multiply it by 100. You will get 25%. This is the answer. 49th, the root mean square speed of 4 gram of helium is 300 meter per second. Total kinetic energy of helium gas is root mean square, that is given by CRMS is equal to square root of 3RT divided by capital M. So already root mean square speed is given, that is 300. Substitute that. Square root of 3RT. M means how much? 4 into 10 raised to minus 3. So RT is equal to how much? 120. On solving you will get RT is equal to 120. Therefore total kinetic energy is equal to 3 by 2 nRT. This is the formula that we have. So 3 by 2 into 4 by 4 into 120 is equal to 180 joules. This is the correct answer. Then 50th, an ideal gas is taken around the cycle ABCA as shown in PV diagram. The net work done during the cycle is equal to. So work done, how it is given? Work done is equal to area bounded by, it is for cyclic process only, area bounded by ABCA. That is how much area is covered. That area if you calculate, that gives the work done. So how you calculate the area bounded by ABCA? ABCA, This is the area bounded by the curve during the cyclic process. So area bounded by, it is a triangle. So what is the area of the triangle? Half into length into breadth. So half. What is the length? Length from this to this you have to calculate. If you consider from this point, the total pressure will be 6P. But I need the pressure from the distance from B to A. Therefore, I will write it as 6P. It is the total pressure, but I need this pressure only. So up to this, how much pressure is there? P. So just subtract the P in 6P. You will get the pressure, that is length, and breadth. Breadth is from A to C. So total volume is from 0 to C is 3. But here it is started from V to 3V. Therefore, 3V minus V will give the breadth. Therefore, how much you will get? Half into 6P minus P, 5P into 3V minus V, 2V. 2 ones are 2 ones are. Okay, how much you will get? 5 EV. This is the work done during the cyclic process. So this is all about the model question paper of JEE mains. In the similar manner, you will get the questions in the JEE mains paper. Just go through the theory and solve more and more problems and solve more and more question papers. So you will get the idea about the question paper as well as questions which will appear for the JEE mains exam. Thank you.